this lecture is going to cover the topic of temperature conversions. And as always, please make sure that you have your objective sheet out so you're aware of what it is that you need to be able to do, as well as make sure that you have a calculator. So temperature, what is temperature? Temperature is going to measure the amount of energy within a substance or within a system. So it's important for us to understand that temperature does have to do with energy. We will discuss this more as we get into different things with energy, but just remember that it's a measure of the energy. And when the temperature changes, a change in temperature, so it gets warmer, it gets cooler, either way, that's going to mean that energy is either absorbed or it can be released. So we all know that the temperature does not stay constant. There is a change, there's fluctuations, and that comes from energy being absorbed and or released. Now, there are different temperature scales, so different ways that we measure the temperature within a system or within a substance. And the first of those scales that we're going to talk about is the Celsius scale. Now, the Celsius scale is used for everyday use in most of the world. Us being one of the exceptions. Okay, so if you were to watch the weather on the TV in a place that used Celsius, your temperature would be in Celsius. So for some of us, we're thinking, I wouldn't know if it meant it was warm or cold outside. So one of the goals here is that you could probably do that by the end of this video because of these conversions. So the Celsius scale is also called the centigrade scale, which means 100 steps. And that is because this scale is based on water. So I'm going to put H2O here, where freezing happens at 0 degrees Celsius. And boiling happens at 100 degrees Celsius. So that is where that centigrade scale comes from, because the scale is based on how many steps it takes to go from freezing water to boiling water. So the next scale, the one that we are probably most familiar with, is Fahrenheit. So that is abbreviated as a capital F. So it is loosely based on the Celsius scale. Oh, not working here. Okay, so loosely based on the Celsius scale. This is used by very, very few countries. So we are one of the few locations that uses the Fahrenheit scale. And it is also based on water. With a freezing point at 32 degrees Celsius, or Fahrenheit, excuse me, and a boiling at 212 degrees Fahrenheit. So you can see how it is actually a little bit easier to remember the freezing and boiling points of water with centigrade or Celsius because it's 0 and 100, but we do have it on the scale that we most commonly use as well. Fahrenheit is not used in scientific research or in scientific labs of any sort, so we will not be using Fahrenheit when we are doing any sort of measurement of temperature. So our last one is Kelvin, and if you remember back to the first part of this unit with metric conversions, this is our SI unit for temperature. So this is what we want to report our temperature in. So the Kelvin scale is an absolute scale, meaning that there are no negative values. So you might be wondering, like, okay, well, there's negative 30 degrees Fahrenheit or there's negative 10 degrees Celsius. There are no negatives in Kelvin. So if you ever are doing a problem and you get negative K, you did something wrong. Okay, so make sure that you're aware of this. If you ever see a negative Kelvin, something is wrong somewhere. So what we call the lowest temperature that is possible is absolute 0 on the Kelvin scale. So it's the coldest theoretical temperature. Now, what does this theoretical part mean? It means we've never actually reached 0 degrees Kelvin. So at this point, it is a theoretical view. But what we believe happens at 0 degrees Kelvin is that all motion and vibrations stop. So in terms of, I'm going to put in molecules here so we know what's actually moving. So with this, that means that any molecules that are moving, remember we've talked about gas molecules and how they're constantly bouncing from one spot to the next. They don't stop. In absolute 0, there is no motion. So if there is no motion, then there is no energy because there is nothing to measure. And if you think back to that definition of temperature, it's our measure of energy. So those are our 3 scales. Now what we're going to do next is we're going to do some conversions. So it's important for you to be able to convert from one scale to the next. So I'm going to give you some equations that we can do for that. So when we are converting from Fahrenheit to Celsius, we're going to use the equation F minus 32, and we're going to divide that by 1.8. Now, this part right here, 100% of the time, you need to have it in parentheses. Because if you remember your order of operations, please excuse my dear Aunt Sally, I'm sure we've heard that before. Multiplication and division happens before addition and subtraction. So if you do not put that part in parentheses here, what's going to happen is your calculator is going to take 32 and it's going to divide it by 1.8, and then it's going to take your Fahrenheit and it's going to subtract it from this value here. You are not going to get the correct answer. So just to cover your bases, make sure that you are using your parentheses. Now from Celsius to Fahrenheit, you're just going the opposite direction. So you're going to have 1.8 and you're going to multiply that by your Celsius term. And then you're going to add 32. This equation, you don't really have to worry about anything in your order of operations. If you want to use parentheses, feel free. It's a great habit to get into. Then from Celsius to Kelvin, pretty easy. All you're going to do is take your Celsius and you're going to add 273.15. That's all. And then Kelvin to Celsius, you take your Kelvin and you just subtract 273.15. And that's all. So what you are going to notice is I am not going to give you an equation that goes from Fahrenheit to Kelvin. If you are asked to go from Fahrenheit to Kelvin, you're going to need to go from Fahrenheit to Celsius and Celsius to Kelvin. Or if I want you to go from Kelvin to Fahrenheit, you do the same thing. You'd go Kelvin to Celsius and then Celsius to Fahrenheit. So So it's important for you to be able to carry those equations through. So doing step 1 and then doing step 2. All right, so now let's do a few practice problems. Make sure you have that calculator out. First one, 14 degrees Fahrenheit, and we want to convert this into Celsius. So what we're going to do is we're going to take our 14 minus 32, and then we're going to divide that by 1.8. So go ahead, get that into your calculator. Pause the video if that's going to take a minute. So what that's going to give you is negative 10 degrees C. Always, always, always important. Make sure that you're including your units. So if you think about this, we have a very good perspective of temperatures in Fahrenheit. You know off the top of your head that 45 degrees is much colder to us than 80. But your perception of Celsius is going to be off for a while until you're used to reading these numbers and recording these numbers. So one way to think about it is 14F to us is very cold. So with the equivalent being negative 10 Celsius, it's a negative number. Anytime you have a negative number in terms of temperature, it's going to be cold. All right, now going from Celsius to Fahrenheit, so we're just going the opposite way. So we're going to take 1.8, and we're going to multiply that by our Celsius, which is 110. And then we are going to add 32. So order of operations would naturally do this section first anyway, but like I said before, get in the habit of using those parentheses. So what we get from this, you plug this into the calculator, you should get something like 230 degrees Fahrenheit. All right, 29 Celsius to Kelvin. So these are the easy ones. We're going to go 29 plus 273.15 equals 302.15 K. Now, Kelvin does not have the degrees symbol because this is the absolute zero scale. So it's not a degree. These are the absolute values. All right, next one, 261 Kelvin, and we're converting that to Celsius. So now we just subtract 261 minus that magic number, 273.15, leaves me with negative 12.15 K. Okay, so it's just a simple matter of plugging values in. All right, last but not least, we're going to do 72 Fahrenheit to Kelvin. And if you remember, there is no equation that goes directly from Fahrenheit to Kelvin or Kelvin to Fahrenheit. So we're going to have to do some multi-step stuff here. So Fahrenheit to Celsius and then Celsius to Kelvin. We just did those problems separately, so now we're just going to put them together. So Fahrenheit to Celsius means we're going to have to use those parentheses. 72 minus 32 divided by 1.8, and that is going to equal 22.2 degrees, and this is in Celsius. So this is our F to C, and now we're going to go C to K. So 22.2 plus 273.15 equals 22.2 35592 295.35. Our unit is Kelvin. Okay, so make sure that you are familiar with The equations, especially, this is where I end up seeing a lot of problems. Not putting that in parentheses. Remember your order of operations. Shouldn't really have any issues with the other ones in terms of the mathematics of the problem. So, go ahead and start working on those practice problems and let me know if you have any questions.